This is the velocity time graph. In this velocity time graph, you can see that this line, this curved line is the velocity time graph. Now this curve is showing which is going in upward direction. It means that the velocity is increasing with respect to time. But here you can see that this curve is showing that the velocity is increasing non-uniformly. And I told you that the gradient of the velocity time graph gives you acceleration. You must remember this point. It is very important to keep in your mind that the gradient of the velocity time graph gives you the acceleration. Okay, now as you know that this is a curve, and on the curve the velocity is changing at every point. Okay, so we have to find out the acceleration on a different points. Now you will see that acceleration will be changing. I will show you that velocity is increasing, although the velocity is increasing, but I would like to show you that if you have the curve like this curve is showing that increasing velocity but decreasing acceleration, although the velocity is increasing, but here in this curve the acceleration is decreasing. Now how we can decide that the acceleration is decreasing? That can be seen from the gradient of the curve. That can be seen from the gradient of the curve. If the gradient is decreasing, it means the acceleration is decreasing. Okay, now how we can find out the gradient at a single point A, for example, and B and C and D? This will be decided, this will be explained later. But here, first of all, with the help of the ruler, I would like to show you. You can consider this ruler as a straight line. Now here you can see that if I am keeping this ruler at point A, you can see that it is more steeper. If I am bringing this ruler at point B, you can see that the slope of this ruler has decreased. Okay, it is lesser steeper. Now if I am bringing it, say if I am taking any point, arbitrary point, say E point, here at E. Now you can see that if I am keeping it at E, the ruler has become lesser steeper. At point A, it was more steeper. It means acceleration is greater as compared to B, because at B you can see that the steepness of the ruler has decreased. So this steepness can show you that the acceleration is decreasing. Okay, now when it becomes horizontal, it means the acceleration is zero. As I told you that the gradient of this velocity time graph gives you the acceleration, and I showed you that if you are not calculating the value of acceleration or the value of gradient, so just from this steepness of this ruler you can understand that the acceleration is decreasing. Okay, now how to calculate acceleration with the help of this velocity time graph? This is also very important point. If somebody asks you that find out the acceleration of the body at point A, okay, listen to me carefully again, that if somebody asks you that find out the acceleration at point A, then what you have to do? You will have to draw a tangent line at A. You must draw this tangent line very carefully. Why very carefully? Because you know that tangent is the straight line which is touching the curve or circle at a single point. Please follow this procedure. What I am going to do, I am going to find out the gradient at point A, and you know that the gradient of velocity time graph gives you the acceleration. So I am going to find out the acceleration of the body at point A. Now as I told you that you must draw the straight line, that straight line will be tangent to this curve. This curve is the graph of velocity time. Okay, now if I am drawing the tangent here, you must take care that this tangent line, this straight line, must touch the curve at a single point. As much careful construction you can do, you must do. Okay, so here you can see that I have drawn this straight line. I try to touch this straight line at a single point. Okay, now from this straight line you will have to find out any 2 points which you are seeing that they are they have the coordinates like the coordinates in the whole numbers. You must try to take the coordinates in the whole number. If there is no coordinate given in the whole number, then it's okay. But here, for example, if I am taking point A, then what are the coordinates of A? Coordinates mean the x coordinate and the y coordinate. Now here you can see that the x coordinate is, because this is 1 second, 2 second, 3 second, 4 second, it means these two boxes are showing 1 second. It means the in between these two there will be the half second. It means this is 0.5. X axis is showing 0.5. Along the y axis, in between 10 and 15, in between 10 and 15 it must be 12.5. Now here you can see that I have taken the points in decimal, I have taken the coordinates in decimal. But what can I do now, because the point A is lying that like this. Okay, now you can see that the point A has a coordinate. The x coordinate of the point A is 0.5 and the y coordinate of the point A is 12.5. Okay, coordinate, this is the x coordinate and this is the y coordinate. Remember this, the point along x axis, the coordinate along x axis is written first and then y coordinate. In the same way, any other point on this straight line, now any other point on this straight line, suppose I'm choosing this point. If I'm looking that this point is giving me value 2 and 35. So say this is point F. I am giving this point as F. So F has the coordinate. The x coordinate of F is 2 and the y coordinate of F is 35. Now I have 2 points A and F on this straight line which is touching this velocity time graph at a single point. What I am going to do, I am going to find out the acceleration at this point A. As I told you that the acceleration can be calculated from the gradient of the velocity time graph. So at point A, because this is curve, we cannot find out the gradient directly, so we have to draw this tangent line as I told you. Now you know the formula for gradient. You can apply rise over run, or directly you can apply y2 minus y1. If you remember this formula for gradient, if you remember coordinate geometry, gradient is equal to y2 minus y1 over x2 minus x1. Okay, this is the formula to find out the gradient. Y2 minus y1, the y coordinate will be subtracted from y coordinate and the x coordinate will be subtracted from x coordinate. Now you can see that on this straight line I have taken 2 points. One is the point A which has the coordinate 0.5 and 12.5, and one is the point F which has a coordinate 2 and 35. Now on this straight line I am going to find out the gradient which will give you the acceleration at point A. Okay, well, now acceleration A, for small a is representing the acceleration. Applying the values y2 minus y1, the y coordinate will be subtracted from y and x coordinate will be subtracted from x. 35 minus 12.5 over 2 minus 0.5. Now let us do this calculations with the help of the calculator. I am doing it. You can see 35 minus 12.5 gives you 22.5. This is equal to 22.5 over 2 minus 0.5 is 1.5. Now 22.5 is divided by 1.5 divided by 1.5. This is equal to 15. So here you can see that the answer is 15. As you know that we are calculating the acceleration. So the unit for acceleration is meter per second square. Okay. This is the acceleration at point A. Now let us find out the acceleration on any other point B. Now the same procedure I am repeating. Please listen to me very carefully, because I just want to tell you that along this curve the acceleration is decreasing. You must know this. Now I am showing you the proof that the acceleration is decreasing basically. Okay, so again I will have to draw a straight line which is touching the curve at a single point B. Now I am trying to draw this line which must touch this curve at a single point. So here I have drawn the straight line which I think is touching this curve at a single point. Now I am going to find out the acceleration at point B. Okay, now one point is the B point, the coordinates of B. The x coordinate of B is 2 and the y coordinate is 25. So 2 and 25 are the coordinates at B. You can also choose any other point on this straight line, but that point must be on this straight line. For example, I can also choose this point because I can see that the at this point the x coordinate is 0 and the y coordinate is 15. So say I am naming this point as E. You can also choose this point. For example, this point has the coordinates 2.5 x-axis and this is 40 to something. So it's better to take this point. It is better point, or you can choose any other point. Like this point can also be chosen, which has 1.5 and 27.5, but it is better to take this point. This point has the coordinates 0 and 15. So here I am naming this point as E. Say this point is E point. I am writing it here. Please concentrate. I am right. This is the point E, which I am writing here. E. E point has the coordinates. X coordinate of E is 0. Okay. And the Y coordinate is 15. Now on this straight line, there are 2 points B and E. Now with the help of B and E, these are the 2 points. I am going to find out the gradient of this straight line. I am going to find out the acceleration at the point B. Please concentrate here. The coordinates of B. The coordinates of B are 2 and 25. 2 and 25. And the coordinates of the point E are 0 and 15. 0 and 15. Now again I am going to find out the acceleration at this point. What I am going to do, I am just trying to show you that the acceleration is decreasing. 25 minus 15. 25 minus 15. As I told you, y coordinate will be subtracted from y coordinate and x coordinate will be subtracted from x coordinate. 2 minus 0. Remember this is decreasing acceleration, not the negative acceleration. 25 minus 15 gives you 10. 2 minus 0 is 2. So acceleration is 5 meter per second square. The unit for acceleration is meter per second square. Now let us find out acceleration at the next point. Now let us find out the acceleration at point C. Again, I am telling you that we are going to find out the acceleration at C. Again, you have to draw the tangent line. This straight line which I am going to draw is the tangent to the curve. And I told you that tangent line is the straight line which is touching the curve or a circle at a single point. Okay, at a single point C. Now I have drawn this straight line. On this straight line, one point can be taken as C. So the coordinate of C are 5.5, or you can also choose any 2 points which you are finding out they are better. For example, no, this is not. I am trying to find out the points which are better meeting on x-axis and y-axis. I'm trying to take the points in whole number. I'm trying to take the points in whole number. Remember this. For example, at the 8th second, if I am looking at the line, it is giving me no. So on the straight line on the 5th second, no, and on this only on the 0 second, I am getting this point. Say this is the point G. One one is the point G. On this I can take the coordinates 0 and 25. 0 and 25, this is the point G. And other point, if you are looking at on this straight line, you will have to look for a point which has the coordinates in whole number. If you don't if you are unable to find any point in whole number, then we can take any point in decimal number also. So I'm just trying to find out if I will be able to find out any point in whole numbers. Okay, so here you can see that I am unable to find any point in whole numbers. This is the point. Okay, this is the point. I located a point. Here you can see that x coordinate is 2 and the y coordinate is 30. It's better to take the point whose coordinates are given in whole number. So this is the point. Please notice that this is the point. So here its coordinates are, I'm naming this point as say E, F, G, H. Say this is H point. I am naming this point as H. Its x coordinate is 2 and its y coordinate is 30. 2 and 30. These are the coordinates of the points which I am showing you. 2 and 30, H point. Okay, you can see it. I'm enlarging the image so that you will be able to find out. Now I am going to write these points to find out the acceleration at this point. One is the G point. G point has the coordinates 0 and 25. The G point has the coordinates 0 and 25, and the H point has the coordinates 2 and 30. 2 and 30. Now again I am going to find out the acceleration at the point C. Okay, I'm not taking the coordinates of C because some student may be asking that it is necessary to take the point C, the coordinates of the C. I told you then on a straight line you can take any 2 points. Please listen to me carefully. On the straight line you can take any 2 points to find out the gradient. Gradient mean in the velocity time graph, the gradient mean the acceleration. So on this line which is touching the curve at point C, I am going to find out the acceleration by taking these 2 points on this straight line, the point G and the point H. Now again the same formula, y coordinate, from the y coordinate I am subtracting y coordinate. You can do 30 minus 25, 30 minus 25 and 2 minus 0. 30 minus 25 is 5. 5 divided by 2 gives you 2.5 meter per second square. Now here you can see this is showing that if I am saying that this is A1, this is A2 and this is A3 and at different points. Acceleration, or I can also write that acceleration at A, acceleration at B, acceleration at C. For your reference only, I am naming this that A mean acceleration at A B mean acceleration at B, acceleration at C is just for the sake of explanation. Now you can see that the acceleration at point A, which I calculated with the help of the gradient, is 15 meter per second square. Now acceleration at B is 5 meter per second square, and the acceleration at point C has become 2.5 meter per second square. So acceleration is decreasing, you can see. So from this curve you can see that the slope of this line is decreasing. So velocity is increasing but acceleration is decreasing. This is also a velocity time graph, which is a curve. In this curve you can see that the velocity is increasing with respect to the time. It means there is an acceleration, non-uniform acceleration. How the acceleration is non-uniform, let us find out with the help of the ruler. As I told you that the gradient of the velocity time graph gives you the acceleration. Now when this is the curve, increasing velocity and increasing acceleration. Previously I showed you that the velocity is increasing but the acceleration was decreasing. I calculated the values of acceleration and I told you that with the help of the ruler you can decide that the steepness of this ruler was decreasing. So this was the case of decreasing acceleration. Now here this is increasing velocity and increasing acceleration, because you can see if you are keeping the ruler at A, the steepness is lesser. If you are keeping the ruler at B, the steepness is more. If keeping at C, the steepness is more. So it means when the steepness is increasing, it means the gradient is increasing, the value of the gradient is increasing. And I told you that the gradient of the velocity time graph gives you the acceleration. So here the acceleration is also increasing. Now let us find out acceleration of the body at different points. Suppose if I want to find out the acceleration of the body at point A. I told you that on a curve you will have to draw a straight line which is touching the point A at a single point. Okay. So very carefully you must draw the line which must touch the point A at a single point. Now I am going to draw the straight line carefully that it must touch the curve at a single point A. So here I have drawn the straight line in a single go. Okay. Now I want to find out the acceleration at A. It means I have to find out the gradient of this straight line which is touching this curve. This curve is the velocity time graph. So I want to find out the acceleration at point A. One point is A. You can see that the coordinates of this point A are 3 and 2.5, sorry. 3 and 2.5. 3 and 2.5. You know that x coordinate is 3 and the y coordinate is 2.5, because this is 0 and this is 5. So in between this will be 2.5. Any other point on this straight line, you can take any other point which is better. I think so this point is better. This, because I am avoiding the fraction, I am trying to find out the points which are in whole number. For example, this is the point D. This point D is on the straight line, not on the curve. So the coordinates of D are, x coordinate of the point D is 8 and the y coordinate of this point D is 10. These are the 2 points. Now what I'm going to do, I'm going to find out the gradient of this tangent line which is touching the curve at A. It means I am going to find out the acceleration of the body at A. The same formula of gradient of a line. The point A has the coordinates 3 and 2.5 and the point D has the coordinates 8 and 10. Acceleration at A. Now here I am writing capital A like this to give the reference that it is the acceleration at A. So please don't get confused with it. It is acceleration at point A, I mean to say, just for the sake of convenience. So I told you the formula y2 minus y1, x2 minus x1. Remember this, y coordinate will be subtracted from y coordinate. 10 minus 2.5. 10 minus 2.5 over 8 minus 3. So 10 minus 2.5 gives you 7.5 and 8 minus 3 gives you 5. Now let us divide these with the help of the calculator. So 7.5 divided by 5. I got the answer 1.5. Here the acceleration is 1.5 meter per second square. So this is the acceleration at point A. Okay. Now I want to find out the acceleration at B. As I told you that this is the curve of decreasing acceleration. Now let us draw another tangent at point B. So I am trying to draw a straight line which must touch this point B at single point. So you must also try to be careful, very careful, so that your line must touch the curve at a single point. Okay. So this is a straight line which is touching point B. This is a straight line. You can follow this straight line. On this straight line, one is the point B. The coordinates of B. First of all, let me tell you the coordinates of B. The B has the coordinate 7.5. The x coordinate is 7.5. And the y coordinate is 15. Okay, here again, one coordinate is not whole number, the x coordinate is not in whole number, the y coordinate is whole number. uh, I can find out any other point on this straight line. It is up to you. One is this point. I'm taking this point. You can also take any other point, like on this line. Wherever this line is going, you can take even in the negative x-axis or y-axis. You can also take any point. As I told you, any 2 points on the straight line can be taken to find out the gradient. And the gradient here in the velocity time graph gives you the acceleration. Now, one is this choice, and other choice for the point may be for me. You can also choose any other point of your own choice. For example, this point can also be taken. This point can also be taken. Okay, because this has the coordinate 11 and 30. Let us suppose I'm naming this point as E point. Suppose I'm naming this point as E. Okay, you can see that E point has the coordinate 11. X coordinate is 11. So I am writing 11 comma this y coordinate is 30. So its y coordinate is 30. Okay, now on this straight line I got 2 points B and E. Firstly, I was thinking to take this point. You can also take this point. So now I'm taking these 2 points B and E. Now I am going to find out the gradient of this line which is passing through the points B and E. Then we will check that what is the acceleration at point B basically. So the coordinates of B are 7.5 and 15, and the coordinates of point E is 11 and 30. Now I am going to find out the acceleration at B. For the sake of reference, I am writing that acceleration at B. Y coordinate will be subtracted from y coordinate. 30 minus 15, 11 minus 7.5. 30 minus 15 gives you 15, and 11 minus 7.5 gives you 3.5. 3.5. Okay, now I am dividing 15 with 3.5. Now let us take another point. Let us suppose I am taking point C. Now I must draw the gradient at point C. So you can see that I am trying to draw a straight line which must touch this curve at a single point C. And I am trying to find out the acceleration at this point C. Previously we got the acceleration at 2 points. So you must draw the line like this. Okay, now this is a straight line which is touching the curve at the point C. One is the point C. You can take the coordinates of C, or you can look for any other 2 points. For example, if I am looking at this point like this on this straight line which is passing through C. Please be careful that which straight line you are considering. This is straight line which is passing through C, because you can see that these are two other straight lines. So you must not be confusing these lines with the line passing through C. That's why you must be very careful while choosing the coordinates of the point. For example, on this straight line which is passing through C, I am taking a point like this. This point had the coordinate, say I am naming this point as K point. Say this is the K point. The K point has the coordinates, the x coordinate is 9. You can see that the x coordinate of K is 9. And the y coordinate of the point K is 17.5, because in between 15 and 20 is 17.5. So this is 17.5. If you are not good in calculations, then you can divide this distance into 2, because these two boxes are dividing in the center. Okay, Now this is the coordinate of the k, which is lying on this straight line which is passing through C. You can also take this point C, or you can choose any other point on this straight line. For example, if I am choosing this point, well, this point, if I am choosing this point, roughly the coordinates of this point is 8 and 5. And I am naming this point as P. Suppose I am naming this point as P, 8 and 5. Okay. Now you can see that I have chosen 2.1 is the point K and one is the point P. I have this straight line which is passing through C. On this straight line, other than the point C, I have chosen any other 2 points like K and P. I just want to show you that you can choose any 2 points on the straight line which is passing through the tangent at that point C. Now one was the point P. P has the coordinates 8 and 5, 8 and 5, and the point K has the coordinates 9 and 17.5. K has the coordinates 9 and 17.5. Now let us find out the acceleration at point C. This is the acceleration at point C, because this straight line whose coordinates I mentioned, this straight line is passing through C, which is the point which is lying on this curve. Now let us find out the acceleration. Y coordinate minus y coordinate of K and P, minus 5 minus 9 minus 8. Here you can see that 17.5 minus 5 gives you 12.5. 9 minus 8 is 1. So the acceleration is 12.5 meter per second square. Now from here you can see that acceleration at point A was 1.5 meter per second square, acceleration at B is 4.3 meter per second square, and then acceleration at C is 12.5 meter per second square. So from here you can understand that this is the curve of increasing acceleration. The velocity is also increasing and the acceleration is also increasing.